Okay, page 4. We're still solving for variables. So if you look at this problem right here, we are going to be solving for p. So again, we need to get p to stand alone, but since it's in both terms, we can just factor it out of both terms. And now we solve for p because this is multiplication going on between these two terms. And the next one, this one is a fun one. We want to solve for a. So we're going to leave x over a by itself on the right and put everything on the other side. So since this is addition, we're going to do subtraction. 1 minus y over b minus z over c. So now I've got to solve for a, but a is in the denominator. So what I'm going to do is I'm going to cross multiply that out of the bottom. So that'll be over here. And then I'm going to cross multiply this big term, this three-part term, to the denominator of the other side, and I'll be done. So I'll have x over 1 minus y over b minus z over c. And that will equal what we're looking for. On the next one, we have we're going to be solving for x. So let's look at this. So I think what I need to do is I need to find a common denominator between both. I'm going to need a little room for this, so let me just pause it while I clear the screen. Okay, I'm back. I'm just trying to figure out how much room I need for this one. So I'm going to rewrite this one up towards the top. So I have 2x over 4 pi plus 1 minus x over 2 equals 0. So I'll find a common denominator. That'll be 4 pi. So I don't have to do anything to the left part. The right part, I am going to just multiply top and bottom by 2 pi. So I'll have 2 times 2 pi. So I'm doing this, I mean obviously I know it's going to be 4 pi, but I'm doing this to tell me that the top has to be multiplied by 2 pi also. So I have 2 pi times 1 minus x equals 0. So now I can combine these. I have 2x plus 2 pi distributing these minus 2 pi x all over 4 pi equals 0. So now I'm going to have 2x. I'm going to factor out a 2x, and that will leave me with, oh, actually, I'm not. I'm going to factor an x out of the first term and the last term, so I'll have x, and that'll be 2 minus 2 pi. Okay, plus 2 pi, that's this term. That's all going to be over 4 pi. So what I'm going to do now is I'm going to separate these into two different fractions. I have x times 2 minus 2 pi. And this will be plus 1/2, because this divided by this is 1/2. And then I'm going to move the 1/2 over. And then I'm going to solve for x. I'm going to just have x is equal to -1/2 and multiply by the reciprocal of that to represent division. And that will be good enough to solve for x. I actually think I can do a little bit more to simplify this. I think, for example, I can the 2 here can cancel with that. So that will be -1. And I'll have 2 pi over 2 minus 2 pi. And then I can factor a 2 out of the top and bottom. So now those 2's cancel. And I am having -1 over 1 minus pi. And then I can finally say that if I divide the negative out of both, I'll have 1 over pi minus 1. So this would be the final answer for that. That one took some work, but we got to challenge ourselves, right? So anyway, moving right along, factoring completely. What's math without some factoring? So I'm going to factor x to the 4th out of this, and I'll have x squared minus 16. And then I'm going to factor this because difference of squares. And that's done. This one, there are 4 terms, so I'm going to just give it a shot, use grouping. And I'll group the first 2. And I'll group the last 2. Notice I'm changing the sign of the 50 because I grouped both of those terms inside the parentheses. So now I'm going to take out the common factor. And I've got x minus 2. And over here I'm going to take out the 25. And I have x minus 2. And this is what textbook math is all about. We have 4x squared minus 25. And I have x minus 2. This can still be factored as 2x plus 5 and 2x minus 5 times x minus 2. So that will be the final answer there. And then for this one, don't want to forget that. That's just a difference of squares. So that'll be x squared plus 1, x squared minus 1, and then x squared plus 1 can't be factored, but x squared minus 1 can be factored one more time. And that's fully factored. So hopefully page 4 is adequate for your understanding of what was done here. I'll be working on page 5. So I hope you like this.